You are stuck at a rest stop with a dead battery, and to get on the road, you need to find someone with jumper cables. So suppose that only 16% of drivers in New Jersey carry jumper cables in their trunk. Do you carry jumper cables? I have some in mine. I think it's good to have. You begin to ask random people getting out of their cars if they have jumper cables. All right, so you're going to give up and call it a tow truck if you don't find jumper cables by the time you've asked 10 people. What is the probability that you end up calling a tow truck? All right, let's think about starting off defining a random variable x. Here, x is going to represent the number of people that you have to ask until you find somebody with jumper cables. So notice here that this is the number of trials until a success. So you should be thinking about this as a geometric setting. Now the probability of success here, P, is 0.16, because that is the probability that a person has a jumper cable. A trial is asking a person. So if we're calling the tow truck by the time we've asked 10 people, if we don't find them, that means that it would be like finding the probability that x is greater than 10, meaning the number of people that we have to ask until we get jumper cables is more than 10. We can't have a fraction of a person to ask. You can't have a fraction of a trial. So that's really the same thing as greater than or equal to 11. So the way that we can think about this is going to be the same thing as 1 minus the probability that we find jumper cables by asking 10 people or less. So this would be 1 minus the probability that x is less than or equal to 10. We can find that using our calculator function, geometric CDF. Our probability of success is 0.6. The second input, whoops, sorry, that's not n, that's p. The second value is 10 because we're doing it for 10 or less. And so inputting that into my calculator here, I end up getting 0.1749. Now, another interesting way that you can think about this problem is that if you have not found jumper cables by the time you've asked 10 people, it means that you had 10 failures. The first 10 were all failures. Then, at that point, maybe the success is the 11th, maybe success is the 12th person, maybe success is the 13th person, and so on. It doesn't really matter because we're just saying, well, the chance that you have to ask more than 10 people means that the first 10 people you asked all didn't have them. So another way to think about it is, okay, let's find the probability that the first 10 people asked don't have the jumper cables. Well, the probability that any one singular person doesn't have jumper cables is 0.84 because that's 1 minus the 16% of people who do have jumper cables. And so if you just raise that up to the 10th, meaning all of the first 10 people don't have them, you get exactly the same answer here of 0.1749. Thanks for watching.